Hey everyone, and welcome to CS121, lecture number 12. In this lecture, we're going to be talking about composition. So this class is called Object-Oriented Programming, which means that we can organize our programs by representing real-world objects in our code. But sometimes the objects that we might want to represent are made up of many parts. You could say that they're composed of smaller components that, when put together, form the bigger, more complex object as a whole. As an example, we might want to represent a car, which is composed of smaller pieces of machinery, like an engine or motors or a set of wheels. We could also represent a dog in our code, which is made up of its tail, its paws, or its ears. Or we could build a video game, which is composed of the players in the game, or the board, or the world where the game is played, and of course, all the other data that's needed to represent the game itself. So composition revolves around the idea that we can define an object with other parts. In other words, we can define an object that is composed of other objects. And a simpler way to phrase this in English is that composition establishes a has-a relationship. Like a car has a wheel, or a dog has a tail, or a video game has a player. So how do we apply composition in our code? The classes that you've seen so far have member variables that are primitive built-in data types. And primitive data types in C++ are like int, double, or bool. Like this TV class that has two member variables, an int and a double. So those are two primitive data types. So how would we store other objects as a member of this class? How do we create a class that is composed of other objects? Let's see how this would work. So say that we want to represent a video game in our code. And a video game can be pretty complicated, and it might be composed of a number of different things. For now, let's just say that our video game class is composed of a singular player. So this is what composition would look like in code. So we have a player object that a video game is composed of. A video game has a player. So essentially, this member variable that we have within the private section in this video game class is another object. It's a player object. So we've established using composition this has a relationship. A video game has a player. So what does this actually enable us to do in our code? So as you already know, we can access the member variables of a class within that class's member functions. So that means that within the start battle function, I have access to the player member variable since we're working within the video game class. And since the player is an object, we can also call its member functions. So we can make those calls using dot notation. So assuming that the player class has a function called fight defined in it, we can apply dot notation on our player member variable to invoke it within the video game class. So now you can kind of see why composition is so important in object-oriented programming. So we can organize our code with objects that are composed of other objects. And this lets us reason about our code a little bit more easily. We can define smaller, simpler objects like a player and leverage its functions within a larger, more complicated object like the video game.